Thermohaline circulation or density-driven circulation. If we start looking at the trade winds that pushes water into the Gulf of Mexico, where this water gets warmed up to about 30 degrees Celsius, and then it's carried by the Gulf Stream all the way to Western Europe, where it starts to lose heat and warm up the Western Europe. And then parts of the Gulf Stream will flow north, becoming the North Atlantic Current. This North Atlantic Current then gets cooled down by storms and sinks, making North Atlantic bottom water. So the North Atlantic bottom water is very, very cold, so it's gonna sink all the way to the bottom of the ocean floor and will travel along the western side of the Atlantic Ocean basin, and it's going to travel all the way down to Antarctica, where it's going to join the Antarctic bottom water, which is the second type of bottom water that we have in our planet. This one being more denser than this one, with temperatures of minus 0.5 degrees Celsius. This is about minus 2 degrees Celsius. So as these two combine, the flow gets deflected to the left due to Coriolis, and they start to circumnavigate the Antarctic continent. But some of this water flows up towards the Indian Ocean or up towards the Pacific Ocean. As this this bottom water is flowing, it slowly will diffuse via upwelling. So this will diffuse upward, returning to the surface. So I'm gonna start showing that with the surface waters with the dashed line. Okay, so slowly that water comes back up via diffuse upwelling in the Indian Ocean, in the Pacific Ocean, and combined, it slowly comes back over here where it gets really warmed up in the Gulf of California, and then the Caribbean, Gulf of Mexico, excuse me. So it gets, the circulation gets started again. So the two bottom waters, the North Atlantic bottom water and the Antarctic bottom water, are the driving forces that is pushing this whole circulation. Now, if there is a change in the temperature of the air temperature, so that will affect how cold this gets, so how much ice melts, how much salt content drop, and the water may not get dense enough to sink. For example, this North Atlantic bottom water may not get dense enough to sink and to power this circulation. That's a concern that is related to the changing in the climate conditions. So again, if the climate changes, the ice is melting, the salt content drops, and the water is not dense enough to sink to power the thermohaline circulation. That's the relationship between thermohaline circulation and climate change.